Good afternoon, everyone, and welcome to Skill-Link's annual Automotive Talent and Technology Trends Event 2024. We are thrilled to have you join us today for this gathering of industry leaders, experts, and innovators. We thank our partners ET Auto for helping us execute this event seamlessly. Today's event is dedicated to exploring the latest trends and advancements in the automotive sector, focusing on emerging technologies, talent development, and the future of mobility. To further our mission of bridging the skill gap in automotive sectors, Skill-Lync conducted an extensive survey with 200 leaders in engineering and HR divisions from the leading automotive firms. The insights gathered from this survey has been compiled into our Automotive Talent Trends Report. We are very excited to launch this today. A quick rundown on the agenda for the day. We have a very exciting lineup of presentations from industry leaders who will share their knowledge and experiences on a variety of topics. I'm honored to share the dais with today's speakers. And here's a quick introduction and the topics they will be speaking on. First, we have with us Mr. Krishna Bandaru, who is the co-founder of Skill-Lync. He'll provide a summary of key insights from our Automotive Talent Trends Report 2024. Followed by Dr. Ranga Srinivas, General Manager, Capability Building at Tata Motors. He'll be speaking on emerging technologies and capability building for sustainable mobility. Up next, Mr. Aaswad Kulkarni, Head of Vehicle Software Architecture at TCS, will speak on the future of vehicle software innovation. Following which, Dr. Shankar Venugopal, VP Technology Innovation and Knowledge Management at Mahindra Group, will speak on Mobility Engineer 2030, Skills and Innovations for the Future. After that, Mr. Ganesh Rao, Head of R&D ADAS Engineering at Continental Automotive India, will speak on software-defined vehicles and how it enables automated driving. Finally, our guest speaker, Mr. Daniel Davenport, Senior Director, Industry Solutions at NTT Data, will be speaking on transforming mobility with smarter software-defined vehicles. And Mr. Dhruv Mathur, Director of Enterprise Business Skill-Lync, will close the session with a vote of thanks. Thank you, everybody, for being here. We invite the audience to share questions in the form available in the chat window. I'll be posting the same shortly. The speakers will answer your questions in regular intervals. We look forward to an engaging and insightful session. Let's get started. Thank you. Firstly, I invite Mr. Krishna Bandaru to speak. So to kick off the event today and launch the report, I'm happy to welcome Mr. Krishna Bandaru, co-founder of Skill-Lync and Creo. Krishna has over 20 years of experience across consulting, technology, and education industries. He's a former MD and partner at Accenture Strategy and has spoken at major events like TEDx, NASCOM, ASME, and Economic Times. Today, he's here to give us an exciting brief on the automotive industry and some key insights from Skill-Lync's Automotive Talent Trends Report 2024. Krishna, please take it ahead.
First of all, thanks a lot. 170 plus people who joined this webinar that Skill-Lync is conducting. I know I am between you and a stellar list of speakers, so I'll try to keep this short and sweet. I'll take about 8 to 10 minutes to cover what are the insights that we've got from the talent survey report that Venkat talked to you about. Number one, the first insight, the first question we asked was, what is going to be the technology focus? What is the current technology focus? What is going to be the focus in the next 3 years? And how will that have an impact on talent demand in the next 3 years? I think there's an overwhelming response which says that while the emphasis on SDV, ADAS will continue, will increase, there's going to be an increasing focus on data and AI. And that will also have an impact on the kind of talent that is required over the next 3 years. I think that is insight number one. The insight number two is, what we asked is, this talent that you require in these new domain areas, is it entry-level talent, mid-level talent, or senior-level talent? Here again, I think the overwhelming response is almost in the new areas of SDV, data AI, autonomous driving ADAS, and to some extent in EV also, almost greater than 60%, 60 to 65% of talent are for mid-level professionals, right? Now, the next question we asked was, where are you going to get these professionals from? I mean, where do you look for hiring such professionals? What are the current methods? While I think all of us know that job portals, employer referrals have been the traditional methods, they continue to be the dominant methods. But what is slowly emerging is whether it is LinkedIn or whether it is upskilling platforms where individuals are investing in reskilling themselves are also becoming a platform to recruit this kind of talent. We also have a case study of how one company actually is using upskilling platform to recruit a number of employees in these areas. The fourth insight is we said, while we understand that you want to hire these particular people, what is the complexity of hiring? How easy is it to hire specific technology professionals? If you see over here, they find it relatively easy to hire mechanical design and analysis or maybe automotive embedded systems. But I think the increasing difficulty is in the areas of automotive cybersecurity and SDV predominantly. We were wondering, is recruitment is the only way out, or can some customized upskilling programs help alleviate this skill shortage? What we found out was people say yes, but what is the complexity of training that is there in this? So almost 60% of respondents say that they find it very difficult to upskill in the areas of automotive cybersecurity, SDV, and ADAS. And also they find it difficult in even automotive embedded systems. This came as a surprise because we thought this was an established area where a lot of programs have already been there. Now, we said, what is the complexity? What is the complexity that they find in upskilling these people? Number one is, I think, given that each company has to do it on its own, identifying the right training content, because these are upcoming technology areas where there is no history, where there is no legacy. Identifying also the right trainers is one of the major difficulty. Almost 1/3 of the people have say that. The other ones are familiar constraints, lack of time and resources, because all the companies that most of you represent want to spend their time mostly in serving your own clients and doing technology delivery, and hence can't spare the bandwidth to spend on training and upskilling new talent, right? And then we asked them, so how do you train people? What are the levers that you use? What are the methods that you use for training people, right? I think the two dominant ones, almost 60 to 70% of respondents said they either resort to instructor-led boot camps, that is live boot camps, virtual live or in-person boot camps. And a lot of them are also beginning to adopt online learning platforms and courses. While they continue to do the other time-tested methods, I think these two are the predominant methods through which they would want to upskill their people. Now, while they do this, we ask them how many, almost 60% of the respondents are already started adopting digital platforms. That's a huge number, right? I'm assuming that the rest of the industry also will follow suit in adopting digital learning platforms to upskill their workforce. Here we want to showcase what we've seen in the industry, given that we work with almost 70 plus clients very, very actively all the time. We want to share some insights on how other companies are solving their talent challenges. First one, I think a leading German tier 1 automotive GCC partnered with an upskilling company to onboard almost 250 plus GETs in an 8-week boot camp. While the 8-week boot camps were always there, they adopted a hybrid learning approach. That is, they provided digital access to some training content even before they joined the company. They conducted live training sessions during 8 weeks. And even post-training, they actually gave access to learning content, digital learning content to all these GETs. So they could retain they could absorb a lot more, and the learning outcomes are better. That is number one. Number two is Indian automotive OEM wanted a 2-year program. That is, they said, we have a number of engineers who've been working with us on traditional technologies, the traditional ICE technologies, and we need to move them to EV technologies, right? And this was like a talent transformation program over a 2-year time period. And the best way to do it, again, was through a hybrid learning method, which is providing them access to cutting edge content plus one-on-one mentoring on a periodic basis, group mentoring and one-on-one mentoring to achieve their electrification goals. An upskilling platform, we launched, given the requirement of classic AutoSAR certification programs, which is one of the niche skills, we said, hey, do different companies want to nominate their people in an open batch? These are not training programs specifically for each company, but a group of companies nominating smaller sets of people to do a program for 6 weeks by doing hands-on activities using the AutoSAR toolkit. This also got a great response. I think it's an economic way for companies to ensure that smaller batches of their employees are trained. The last thing, maybe the other automotive OEM GCC who wanted, again, their entire workforce, to their engineering workforce, in fact, to have access to an LMS with curated learning paths for different departments. The last one was what I was talking to you earlier about, a large engineering services company, which normally goes to engineering colleges to recruit, changed its policy to see if they can recruit 50% of GETs throughout the year. So they approached upskilling platforms where mechanical and electrical engineers were upskilling themselves and conducted recruitment drives over a 6-month time period to recruit, very steadily recruit, instead of recruiting in bulk, steadily recruit GETs over a 6-month time period. There are numerous case studies like this, but we thought we could share some of these from our experience. Now, coming to the last slide, what should companies do? Given these changes in technologies, they have to innovate, right? Either for recruitment or upskilling across the employee life cycle. Our recommendations are, for recruitment, companies need to explore new channels of talent acquisition. While the traditional channels are there, they should go to upskilling platforms to identify individuals who are investing in reskilling. Provide, even when you are going to colleges, how about providing upskilling platforms to college students over a 12-month time period, and actually select students who use the platform to upskill themselves and actually select those who've improved their expertise. We are working with one tier 1 GCC who's trying this approach out across about 20 engineering colleges. Coming to upskilling, I think onboarding of early working professionals, whether we call it the GET program or early working professional program, I think it's time to revamp it. I think there's only a certain amount of bandwidth that one has within the organization. Have niche external partners and also adopt hybrid learning models, right? It's not entirely online, it's not entirely offline, but hybrid learning models. This can drastically reduce the lead time for deployment of these resources onto live projects. I heard one CEO of a tier 1 automotive OEM say that what earlier they used to have 8 months before they could deploy mechanical engineers to really live critical projects, they could reduce it to 3 months by following this approach. Also for existing employees, because I think the skill gap cannot be completely filled with only recruitment, upskilling of existing employees through focused boot camps and access to cutting-edge digital libraries. I think it's time to make integrated learning programs as a key lever for both career development as well as retention. Those were the insights. I'm sure Venkat will ensure that all of you get this report post this event. It's a great read. It has very elaborate findings, and I really hope you enjoy the next 5, what the next 5 speakers have got to say. Thank you. Back to you, Venkat.
Thank you, Mr. Krishna. Up next, we have our first speaker, Dr. Ranga Srinivas Gunti, research and product development specialist with over 20 years of experience in the mobility industry. Currently, he is the head of talent development and at Tata Passenger Electric Mobility Limited, Tata Motors. Dr. Gunti is responsible for creating and implementing capability building roadmaps, competency frameworks, and digital transformation initiatives. He is also an honorary adjunct professor at Virginia Tech India and IIT Madras. Today, he will share his expertise on emerging technologies and capability building for sustainable mobility. Please welcome Dr. Ranga.
Big thank you to ET Auto and Skill-Lync for giving this opportunity. So before going ahead, I just also want to thank uh, distinguished speakers today. And my special mention and special pranamams to Dr. Shankar Venugopal, who is my well-wisher, and we are also colleague in my previous organization with Mahindra. So I have some 10 slides. I just try to put a crisp of few things on why capability building and how is the emerging technology landscape, especially with respect to mobility, and then how to build capability. Right? So why capability building? So if you see, one of the objectives of capability building is to manage disruptions, and then also to create a talent pipeline which can feed in to various projects which the business has to deliver, short term and long term, and then create a technical specialist or SME roles within the organization, which will enable companies to innovate. So these are some of the three objectives why we need to do capability building initiatives. So first one, if you see managing disruptions, today we are seeing a lot of transformation from fossil fuel to electric, hybrid, and fuel cell vehicles, and driver dependent to autonomous and connected, and hardware defined to SDVs. Right? We all know this. And product experience to entire customer experience. We are also talking about how can we give a differentiated customer experience to those who buy both in-cabin experience, digital, physical, so on and so forth, and across the life cycle of the product. So how can we create a differentiate? These are some of the four high impact areas where transformation is happening. And most of the organizations, the current manpower pool is maybe at least last 2-3 years, or last 5 years, a lot of work has been done by various OEMs, tier 1s, tier 2s, to transform people with the ICE-based skill sets to EV and so on and so forth. This is okay piece. Now, when we talk about driver dependent to level 1, level 2 plus autonomous, so most of the companies, OEMs who are manufacturing automotive, they are already giving ADAS features. But if we are ambitious to launch level 2 plus vehicles in Indian roads, and a lot of work has to be done in the capability and skill development areas, especially for both start from technicians till the chief engineers level, because a lot of technologies are coming, AI ML based, computer vision based, sensor fusion, and many, and then telecommunications, connectivity, cellular. A lot of other technologies are getting converged to create a differentiated customer experience to those who are buying our vehicles, especially for safety use cases. If we talk about Indian conditions, we focus on safety use cases. This is one thing. Then HDVs to hardware defined to SDV. I think one of the speakers is especially talking about this SDV, so I want to skip this. And I already spoke about product based, only looking at product based to how we can actually engage the customer throughout the life cycle. These are some of the transformations happening, and these are going to affect the complete automotive, not only OEMs, their suppliers, their channel partners, the entire ecosystem it's going to affect. So engineering part, operations part, manufacturing, assembly, then sales, service, marketing, the entire value chain is getting affected, both people, products, and processes. Now, with this, so how to manage these disruptions? One way is to have specialized interventions in the area of capability building. We'll talk about that. Then also there is a need for creating a talent pipeline. So when we say talent pipeline, those who are currently making ICE vehicles, there is a fundamental transformation in the assembly lines, in the supply chain, and also in the service part. When these vehicles move out, EVs move out, the service part. So how the existing talent who are on roles can be groomed towards these areas which we spoke about in the previous slide. So that's a big challenge. So that's one thing. So how do you create people who are subject matter experts, a few subject matter experts, specialists we call, and a few with the basic and intermediate proficiency level who can become practitioners. So how do you do that? So this is one big question, creating a talent pipeline who can be fed into the live projects. Then why capability building? Again, we wanted to create some SMEs. So I have one slide on the technical ladder. So today we are talking about technology disruptions. We are not speaking about the business model disruptions. We are talking about the technology disruptions. And to manage these technology disruptions, there is a need for creating a separate path for those who wanted, those whom we wanted to become subject matter experts in their functional and domain areas. So the reason is the people start their career, they get into operational roles, then they get into managerial roles, and they start leading some subsystems functions. But not everybody can become people managers or people leaders, and also the requirement for people leaders and people managers may be relatively low in an agile organization. So one thing is, can we at let's say 5 to 10 years of experience, can we create a separate path for a person with giving some interventions and grooming them in a systematic way, so that the companies have a pool of subject matter experts who can create white box models. For example, today we are talking about in SDBs, we want to directly work with chip manufacturers and directly working on white box. For example, control systems, we wanted to get into the details, white box based physics-based models and 100% transparency to solve. So for example, an EV stops or a bus, electric vehicle bus stops at somewhere. Now, if you want to do troubleshooting, the OEM should have few SMEs who can get into the root of the software-based software and start solving those problems, number one. So there is a lot of transparency required. Even if we want to optimize our systems, the fundamental, the physics part, the math part has to be decoded. And all these things require OEMs to have core SMEs. So this is one thing, and which will also help organization to optimize the aspirations, right? Now we will see how to build capability. So we saw why capability building. Now let's see quickly in another 5 minutes how to build capability. So first, research and benchmarking. Perform a thorough research and benchmarking on what competitors are doing, what the various tier 1, tier 2, what startups are doing in specific areas, and how the technology disruptions are happening and how business models are changing, especially with respect to passenger car or commercial vehicles. Thorough benchmarking. So this requires a effort by a cross-functional team. So this has to be done in a very systematic way, and OEMs are doing that. Then competency and skill database. Have a comprehensive competency and skill database across functions. So right from technician till the chief engineer, we need to actually have a database of their skills related, and then have their job roles in place, and then map the job roles to the competencies. This exercise has to be systematically done. Then once we do this, then we can come up with some frameworks wherein we can do the gap assessments, functional competency-based gap assessments. Then once we know the gaps, definitely we can create a capability building roadmap, both short-term and long-term. So one thing I would like to show in research and benchmarking, what's happening, especially in the automotive. So if you see here, I would give courtesy to Cywell. Cywell is a platform where lakhs and lakhs of documents are there, publications, invention disclosures are present, where we got a chance to work on this Cywell with Elsewhere team. So what's happening is, if you see BYD, they're focusing on engineering, and their next focus area is material science. And then, of course, computer science, math, physics, and of course, sustainability related areas. Now, Ford Motor Company, we've gone through the documents which are in the Cywell database, and they're focusing in engineering and environmental science, and of course, physics, maths, chemistry, related to sustainability, battery chemistry, so on and so forth. Tesla is essentially focusing on engineering, but their focus area next is computer science. So most of their second focus area is computer science. We all know that why. And then Toyota Motor Company, again, it's a traditional automotive company, which they are focusing on engineering, environmental science, computer science, chemistry, sustainability initiative, hybrid, so on and so forth. Now, why I'm picking up this slide is that if you see all the OEMs have all the successful OEMs have strong focus on STEM part, because to make things white box, we need to fundamentally go deep dive into the physics part of the problem, and then try to make black box to a white box so that we can have control and do system optimization, or we can solve the problem, right? So people are focusing on STEM. Apart from STEM, their mobility, material science, chemical engineering, so on and so forth. Now, if you see the next slide, I just tried to note within that what they're focusing on: BYD, control systems, forecasting excellence, optimization. Ford, again, it's a traditional company, so we are saying vehicle engineering, autonomous. Forecasting excellence is coming predominantly using AI/ML. Then, of course, optimization. Tesla is heavily into electric, inverters, battery, power electronics, software. Then Toyota, of course, they are also into hybrids heavily. We all know this, energy efficiency. So more or less, most of the successful auto OEMs are focusing on the new areas, AI/ML. So this is from 2015. They started these interventions since 2015. They started building their capability in these areas. Okay. So focus on STEM, we saw digital SDV is one part, and also AI/ML, how to leverage AI and ML across the value chain, how to automate the processes, how can we leverage Gen AI to really automate the processes, and then sustainability. So environment, social and governance, this is another sustainability norms are going to come. So everything, every department, every function is looking at sustainability as one of these checkpoint in whatever they are doing. So this is another area. Now, so now we saw research and benchmarking, we saw competency and skill. So now we saw how to do research and benchmarking, get the themes, focus areas, then bucket those themes and focus areas and come up with a competency framework. So grossly, these competencies can be bucketed into these areas. Fundamental science, bucket those competencies, which cuts across all the areas. Then domain-specific competencies, bucket in each of these areas. Then the competencies related to innovation, sustainability, knowledge-based engineering. And then there are 200, 300 emerging technologies which are coming up. And out of this 200, 300, there are 40, 50 which can be made relevant to automotive to create a differentiated customer experience or to solve problems. Bucket those competencies here. Then, of course, delivery excellence, business acumen, and technical leadership. Bucket. So bucket those gross competencies and then create definitions for those competencies and then make it relevant to each of the function departments which are in your organization. And then try to map these few critical competencies, 4 to 5 or 5 to 6 to the employee roles. And then once the employee role is mapped to these critical competencies, maybe 4 to 5, then start creating the knowledge interventions, capability interventions, or the skill gap assessment interventions based on those competencies which are tagged to their role. So this is one thing. This is one structure. Then we talked about gap assessment. And when we do gap assessment, remember we should do gap assessment not only for the OEM, also the suppliers. Suppliers have to come up to our speed, OEM speed. So look at the suppliers ecosystem and try to do gap assessments. Then also the channel partners, so on and so forth. Now, once we do this gap assessments, then we can get into education mode, education skill-based and experiential learning, only skill-based and experiential. So the classroom trainings are becoming obsolete in the sense that every classroom training should be having post lab-based interventions and the project-based interventions. And then proof of concepts with startups, academia, and government labs. This is something where the capability building will happen while a person is getting exposed to a challenging problem and working with startups or an academia, relevant academia to deliver a particular or prove a particular concept and then take it to the production level. So these are some of the things. Now we saw, so how to build, we started off with research and benchmarking, then competency database, then assess the gaps in a systematic way, then create a capability building roadmap. Once we do this, then I think we should get into engaging with various academia, startups, and then suppliers, and then also have some open forms. For example, Eclipse is one of the consortium, open source consortium for SDVs. So start working with various consortiums, and then with various agencies like SAE, IEEE, CII, and then search out various funds. Government is releasing a lot of funds in certain areas and try to figure out those government funds where we can leverage and then improve your own infrastructure to create a capability building intervention. So that's all with me right now.
Thank you
So
so
I
much,
think,
Dr. Ranga.
yeah. So
Yeah, just we have just one question for you. So how do you prioritize which emerging technologies to focus on for capability building at Tata Motors? We have this one question from an audience member.
So the question is, how do we so I will talk in general, any automotive OEM, how they should prioritize. Is that okay? In general, how should we
Yes.
prioritize? EVs, let's take an example. So EV, recently there is a pull in hybrids. Now things are slowly changing. Take 3-4 themes. First of all, come up with 10 to 15 themes based on how world is changing. And out of 10 to 15 themes, prioritize some 3 to 4 top themes, wherein you have to carpet bomb. Immediately, you have to carpet bomb the entire organization, sensitize them on 2-3 areas, all levels, all functions. Then once you carpet bomb on 2-3 areas, then you go deep dive into various functions. And then for each of these areas relevant to that function, try to create a very structured 6 to 8 months intervention. It can be a certification program, or it can be a PG diploma program, short term. And for long term, you can sponsor them to various universities, maybe for PhD, for a doctorate degree in certain areas. Like quantum computing, you can sponsor 2-3 people in quantum computing related to cybersecurity, PhD, or MTech, you can sponsor MTech, then BTech long term, but short term, you can come up with certification courses. So identify 3 carpet bomb, function deep dive, and then take a larger pool of people and then send them to various certification programs. This is how, in general, I think any OEM.
Thank you for sharing specific case studies on what areas are being targeted by other OEMs as well. Thank you so much. Mr. Aaswad, I'll give a quick introduction of our next speaker. Next we have Mr. Aaswad Kulkarni, who has over 23 years of industry experience in software development across multiple sectors, including mining, locomotives, robotics, subsea solutions, and automotive. He is currently leading the SDV efforts at Tata Consultancy Services as the head of vehicle software platform. Mr. Kulkarni has in-depth knowledge of software architecture, design, and development of control systems. Today, he will share his insights on the evolution and technology elements within SDVs. Mr. Aaswad, please go ahead.
Thank you. Thanks a lot, Mr. Venkat. And hello, everybody. Good afternoon and good evening, good morning if other folks from geography have also dialed in. I know one of our speakers is sitting in US right now, so a very early good morning to him as well. As Venkat introduced, I have been in the industry across different domains. So what I've had a chance to see essentially is how different domains try to approach the software architecture, how we try to approach developing the software in a particular way from a legacy to a much more standardized or much better architected way. So all of that is kind of culminating into how SDV and the automotive industry is shaping up. I know so far you can't see any screen because now I'm going to share. I'm going to continue on. If there are any hiccups, Mr. Venkat, please let me know. Right, so what I'm going to jump into, and I'll try to keep it short and sweet, is essentially, talk a little bit about what I see as SDV, what is happening in the world, why are we doing what we are trying to do, and then go into a little bit of the technology elements, what used to be present, what we are seeing today, and potentially how new technology elements are going to come in, and what we as an organization as well do in this particular space to keep ahead of the curve or to keep in sync with where the world is moving. And obviously, I'll specifically focus on all the automotive part of things. So going here, essentially what you see on the slide is the part of how and why of the SDV. Why are we talking of software-defined vehicles? Software has always been present in the car for many years now. What is changing? Why are we saying it is software-defined rather than we were not saying it earlier? I think it's driven by quite a few elements. It's driven by the architectural change that's got inside the car. It is driven by some of the technology elements that have shaped up simply because of the needs of the new cars. And the needs of the new cars is essentially driven from different aspects. One is ADAS, and I know a speaker will go into much more details into the ADAS side of things, so I'm not going to go there. But that's been one of the driving points trying to move towards the autonomous aspect as well, which is bringing a lot of changes for any given vehicle. And obviously, it's not limited to passenger. It's also to commercial vehicles. There is software-defined two-wheelers that we are talking about right now. So it's not really limited to a passenger vehicle car only. But what you see on the screen essentially is, the four pillars, so to say, the four driving points that we see is bringing the software-defined vehicle. You would have heard of feature on demand, subscription services, users or our car drivers needing a particular functionality only in a particular geographical location or only for a certain time period. They will subscribe, unsubscribe, and being able to utilize that service. Now, what it means from a software definedness within the vehicle is the ability of the vehicle to be able to support such a functionality, that something can be turned on, something can be turned off. So what do we need to do inside the vehicle from a technology perspective is A, being able to support this turn on, turn off. B, being able to, let's say, push something over there when it is required and take something off when it is not required. C, make sure that the hardware, that your vehicle is already capable of handling this change of which is going to happen when somebody subscribes and when somebody unsubscribes. So those are the technology element pieces. Those are the considerations from the architectural perspective that go behind all of these elements to be. So we can't simply say there is a subscription service and it should work. All these considerations when we are designing the software, when we are implementing everything within an ECU or an HPC, as we call it nowadays, and bring it into the actual vehicle. Now, so similar things moving ahead are around data. What is the data being collected from the vehicle? What is being pulled into the cloud? What is its purpose? A person sits inside the car and the car recognizes it's you and does all the settings for you, your steering setting, your seat setting, and then let's say the ambience inside the car, a certain color combination on your infotainment system, the lights that you see across the car. All of this could simply be changed based on a link between the two pillars that you see here, an immersive experience and what is being collected as data and being analyzed and then repurposed for future use. And so what we see of the car is the third one from the left essentially is the purpose-built part. Look at the car as something more than just a thing to drive from A to B. I'll share one interesting thing that I saw over the last couple of years. 2 years ago, I was at the Consumer Electronics Show and sitting in a booth and pretending I'm in a car, and it walked me through an experience of you're going from point A to point B. This is the route you always take. You are in an EV, so this is the battery charge that is currently there. This is the battery life left, and this is your usual route. This is where you take your coffee regularly. Shall I go ahead and order it? Because more often than not, you end up taking that detour. End up taking that stop. And I can order it upfront for you so you can save time. And let's say the charge is not going to be enough, then it will get a notification here are the closest charging stations. Shall I book it ahead for you? And you can complete the charge and reach your point B. Now think of all of the considerations from a software point of view that went behind being able to realize this. Not only has it to be supported within the vehicle, so the capability of the vehicle, the capability of the hardware and the software elements which form all of this are required, but also the safety aspect, the security aspect, because now you're talking of third-party ecosystem, you're talking of cloud solutions, all of which has to interact. And all of these considerations, every vehicle maker and every tier one, every software players like us have to consider, have to look into, and enable. So this was, to an extent, bringing a particular software definedness on the vehicle. What I saw this year, earlier in January in CES, is kind of a second step towards this evolution, if you will. Now, all of this is fine. All of this, which I described, is still the case. It's still something the users want, or the companies want to provide to the users. That's the ease, that's the convenience part. Next step was now don't limit all of this to just the user. How can we derive more benefits out of it? And it was provide a reward program. Let's say you're using EVs, you're saving certain carbon footprint has been reduced around it. Make a reward program out of it, and not just a reward program for the user. You can obviously shop using the reward points or the loyalty points that you have accumulated, but you could even donate it. So donate it out to an ambulance service, for example, or donate it back to the grid, and then you keep collecting the points and donate it for the larger society benefit. So this is an expansion of the ecosystem that is available with the manufacturers, with each and every vehicle, and taking it to the next step. So that's kind of how I see the evolution of the vehicles to bring in the software definedness, to be able to implement it and B, benefit from it. There's no point in just implementing if you can't derive the benefits the right way. And what it leads to is essentially the bottom part that you see on the screen there. The business model, one part is obviously making money out of it by doing all of this. So how is the recurring revenue coming? But to realize all of this, what major impact it has had, and it continues to have, the evolution of it is, one is more and more inclination towards doing in-house software. Dr. Ranga also talked about a bit of OEMs needing that expertise, OEM wanting to have certain SMEs, even if everything is not being done, the SMEs are very important. So it's kind of the thought process from there is doing the in-housing part, being able to understand, and not just understand, being able to build also all the elements that are needed, so that we have a tight ownership, we have the flexibility to be able to release software as fast as possible. But now, when I say all of this, what's happening has been happening in the last 3-4 years, and it continues to grow, is the collaborations piece. One is obviously the collaborations between OEMs and the technology players, OEMs and service players, OEMs and tier ones, or even across OEMs. We see quite a few of examples of across OEMs as well. But now what has also happened is there are a bunch of consortiums. Ranga took one example of Eclipse SDV, which is focusing on the open source part of things. So hence the non-differentiating software, as we typically call it. Differentiating is what every OEM wants to provide. But there are consortiums. Obviously, AUTOSAR has been there for 20 years. It is continuing to evolve with newer standards like Adaptive AUTOSAR to focus specifically on the HPC. We have Covesa, which used to be GenEV, which is now focusing on the connected vehicle parts of it, trying to standardize the data, which is coming off of the vehicle, going into the cloud for whatever purpose, going for insurance industry, going for other analytics, so on and so forth. Then we have Sophie, which is focusing on some technology aspects of bringing the cloud native paradigm into the vehicle. So using containers, using containerized-based technology, which has been there in cloud for many, many years, bringing all of that down into the embedded world, simply put. Now, the further step that is happening here is these consortiums existed. Some are just 2 years old. I think Sophie is only 2 years old. Eclipse is also relatively new. Like I said, AUTOSAR is 20 years old. But for SDV to be realized, what everybody has realized is bring all of these together. So for example, there's an SDV alliance out there, which is the alliance out of these 4 consortiums that I just talked about, who are saying we are focusing on different areas that matter to SDV. Now let's try to work together and see where the overlaps are, where they aren't, and how do we define standards, how do we define recommendations, how do we build certain software pieces that marry all of this together, and you can accelerate your SDV. So that's where everybody is moving. and I'm trying to be cognizant of the time so that I don't spend too much time on all of these topics. So that's where essentially, where we see the SDV part coming and how the industry is shaping up for the continuous evolution happening. With that, I'll quickly jump into some of the elements, the technology elements, as I was saying, or the architectural elements that are happening in SDV. Now, what you see in the picture and what is written, excuse me, is essentially where it stands today a little bit and where we see it going next. Some things that I see are happening. The E architecture has evolved. We know that. We used to have distributed ECUs. We went to domains. Now we are talking of central computes, high performance computes, consolidation of the domains, and so on. So that's something we are very well aware of. Slightly new things we see happening inside the vehicle that I have noticed is some redundancy parts being brought in. Now we are talking of zonal computes, which are going to do the IO operation. What happens if one goes down? You need hardware as well as software capabilities to be able to still have the vehicle operational. So that's one thought process which is coming in, which I think probably will become a bit more common as we go ahead, especially when we talk of more autonomous levels required in the coming future. When you talk of the platform part, essentially, it used to be embedded ECUs, OS/X, and now Linux was there. Android has been there for a few years. Now we are seeing flavors. They're coming into Linux, QNX operating systems, other operating systems coming inside as well. Linux has picked up such a lot that there is Safe Linux. We have a couple of companies which have been working on the Safe Linux part of, so you have a safety certified kernel, you have a safety certified operating system, which, as all the automotive players will know very well, is important from an ISO 26262 functional safety perspective. So those are the newer elements that are being focused by different companies, and we have to work on realizing it into our SDV architecture. In all of this, I think diagnostics was one piece that Dr. Ranga also touched upon a little bit. Safe cybersecurity, functional safety, I talked about. These are fundamental considerations that are to be kept always in mind right from day one when any software piece, any vehicle is being designed, is being implemented, because otherwise we are going to, you can't look at it too late. I know, I think I think pretty much all of us might have experienced a certain event that has happened today, which might have disrupted some folks joining in a convenient way. And, so we have seen live today itself what a disruption can bring to our day-to-day operations, and think about it hitting the vehicle as well. So quite important, because safety of the people riding inside is of paramount importance. Another thing that we see essentially from an architectural perspective, what is evolving is what I've mentioned there as the vehicle and platform services. That's essentially a layer, a vehicle operating system that every manufacturer is trying to look at, where we have a common software platform going across multiple vehicle lines, and we don't keep redoing the software across multiple vehicle lines. You have a common architecture. When I say services, it's more SOA, the service-oriented architecture, which is becoming more and more common. And that's one of the more, within the SDV, one of the elements that from a training perspective, from a learning perspective is required as well. So that's the layer that everybody's talking about. And obviously on top is now the re-architecting of the features, the re-architecting of the vehicle applications that used to exist in a signal-based world, A to be made SOA-based, B to be integrated with these vehicle services that we have brought, so that we can derive the benefits that I was talking about earlier: faster turnaround, more flexibility. All of this requires initial investment, but the benefits are seen as we continue evolving or continue releasing more vehicle lines, more vehicle programs, more variants, so on and so forth. And of course, our top is the cloud, which is a must-have. No way of running away from a cloud infrastructure needed for any SDV part. And on the top right that you see, the containerized services in the cloud as well as in the vehicle is something everybody's moving towards or trying to move towards. I took the example of Sophie. I was presenting at the AutoSAR conference last month. Sophie was there. They mentioned, how things are evolving. So from an evolution perspective, it's not easy to bring into the embedded world the containerization part. You have functional safety, you need mixed safety criticality orchestration to be done. And Sophie mentioned in the conference that we will bring a specification out somewhere in 2025. So that's the time it takes for the evolution to happen. That's the time it takes for organization to focus, start standardizing things so that we can derive the benefits. There's quite a few things in SDV are not standardized yet. That's the way it stands in the automotive today. And with that, I will finally switch to my last slide. As mentioned, I'll have only a few slides, but what I talk about here essentially is how we as TCS kind of focus on all these elements that I just talked about and described in short as well as possible. What we focus on is obviously we are trying to serve our immediate customers on the journey that they are taking, but at the same time we want to be ahead in terms of anticipating where the industry is going to head towards and what our customers might need in future. And obviously around all this, one is the theory part, other is trying something out, practically realizing it and be able to showcase it. So that's where we focus on the readiness from the future technology perspective, but also having a lab itself where we bring in the latest pieces of hardware, bring in the latest pieces of technology, create some solutions around it, run the proof of concepts, create some demos, which we can showcase, not just on the current technology, but use futuristic part as well. For example, we play a lot around with containers, which will probably, like I said, come next year as a more prevalent piece within our technology. But that's something we are playing with today, for example. Obviously, all the other piece, generative AI, the analytics around vehicle diagnostics, the data being pulled across into the cyberverse, so to say, as I was talking about earlier. Security, safety always remains on paramount. So all of this kind of going into what is SDV and around all the different domains that you see in the picture there, autonomous cockpit, electrification, as the main domains that we touch about. So bring the trends, look into the architecture, create labs, create solutions with all these new pieces of technologies on newer hardwares as well as cloud. I think maybe somebody will touch upon the virtualization on the, let's say, on desktops, on the cloud, so on and so forth. But all of these pieces are something we actively focus on and kind of stay in step and a few steps ahead from a technology perspective. So that's the gist that I wanted to cover overall. Venkat, I don't know how well I did on the time, but with that, I'll take a pause and I'll hand it back to you.
No problem at all, Mr. Aaswad. I'm happy to hear you. Thank you so much for such an insightful session. We have one question. We have we have a couple of early career folks and some in academia as well joining in here. So they want to know some of the critical skills required for students as well as early career folks, how to get into SDVs as a career path.
Okay. And I'll give this as a personal answer, not necessarily an industry-wide answer, but the way to look at it, and especially I think, Shankar, you mentioned early career or college folks who are just trying to join in. One is obviously the stream that you are in. SDV is a very big term, and it's vast, as I threw in a lot of technology terms, lot of domains. So what you need to look at is obviously try to pick the interest area that you are in. And within that particular interest area, see where the technology is shaping up. So for example, if somebody is in ADAS and looking at AI, ML, continue to look at it, and because that is definitely a growing area. And I'm just taking examples here. Other would be somebody who is into the embedded side of things, into the embedded world, realizing the software on, let's say you're just playing with Raspberry Pis right now, but you're playing with Raspberry Pis only with the Raspbian OS. Don't limit yourself to that. There are Yocto distributions of Linux out there. So try something with that. Take that flavor, learn that technology, because that is something definitely quite important. That is continuously growing. Like I took the example of Safe Linux. So you'll have more Linux-based distributions, for example. And once you learn one, let's say you are tomorrow put into a QNX based project, it's not a very steep learning curve. There is some learning curve, but it's not ridiculously steep because you have played with, let's say, Linux quite a bit. So I just took two examples. Obviously, it's vast if somebody is in digital cockpit side, Android, or even somebody in the lower layer talking of VertIOs could also have a technical niche skill to be developed, which is required in that particular domain, but may not be required on, let's say, the AutoSAR or Linux side of things. So try to identify that. If you can find A, the area you like, B, certain niche aspects on it, you have your future sorted out as as much as I can predict. Thank you.
Thanks, Mr. Aaswad. With that, we'll invite Dr. Shankar to the dais. Dr. Shankar, glad to have you. Just a quick introduction about Dr. Shankar Venugopal. He is the Vice President at Mahindra. He leads innovation and intellectual property initiatives. Dr. Venugopal's expertise in technology scouting and R&D management has driven Mahindra's technical transformation. And as the Dean of Mahindra Technical Academy, he is committed to nurturing talent and fostering a culture of innovation. Today, Dr. Venugopal will discuss Mobility Engineer 2030, skills and innovations for the future. Over to you, Dr. Shankar.
Thanks a lot, Venkateshwaran. Very happy to be here as part of this panel. And maybe I should start with thanking Krishna, Ranga, and Aaswad for setting the context in terms of the big shifts that is happening in the technology space. And I will focus more on the question that you brought up, which is what kind of skills would the early career professionals and students would need to basically play a role in shaping up these new technologies. I will specifically focus on this aspect today. Sure. I wear two hats at Mahindra. One is to build a pipeline of new technologies and drive innovation for new products. The other is to build capability amongst our engineers in all these new technologies so that they'll be able to leverage all the good things that's happening in this technology space and translate that into innovations that the customers would really appreciate. So I'm going to leverage that second part and wear that hat as the Dean of the Mahindra Technical Academy as I share what are the key skills that we would all need to be in the emerging automotive space. Sure. So give me a second to pull out my chart and then we'll get going. So we did hear about the tectonic shifts that's happening in terms of technology disruptions and also business model disruptions in the traditional automotive industry. So what I will focus on is what kind of skills would we all need to build for ourselves and also for our colleagues in our own teams. Also, whenever we interact with students who are aspiring to come to the automotive industry, what should be our guidance to them in terms of what that to focus on if they want to contribute to this emerging mobility space. And these are the skills that we should really address because some of these are technical skills, some of these are cognitive skills, and it takes time to build these skills. And the engineering skills are fairly straightforward. We do see that what was a purely mechanical engineering domain has evolved into a combination of mechanical, electrical, electronics, and also programming skills. So it's difficult to create a hybrid engineer who is equally skilled in all these areas. So at best, our best of best universities create engineers who are good in one of these areas. And so all of us, whether you are already in an automotive industry or you are aspiring to enter the industry, you have to go ahead and pick up all the other complementary skills that are needed. If I'm a mechanical engineer, it's on my own effort that I have to build the electrical, electronics, and programming skills. And today there are a lot of resources available, which makes it easy to go beyond the classroom and pick up a lot of these skills. The second is what we call as integration skills. That basically looks at how we are able to understand the needs of the customer, how we are able to build a product of very high quality, how are you able to manage things at a system level, build good communication skills, and collaborate with people with complementary skills. These kind of integration skills becomes very important. These are not taught in a classroom. Maybe we will pick up these skills as we work in projects and summer internships. That's where these skills we will get to hone. The third part is a growth mindset that would involve having an innovative mindset, having the right ethics and values, and most importantly, what we call as learnability, because there are going to be lots and lots of new technologies coming into the space. We heard about the software-defined vehicles and the portfolio of new technologies that comes along with that. So the learnability, ability to learn new technologies whenever there is a need, I think these are all going to become very, very important going forward. So I do this on a quarterly basis. There is a Society of Automotive Engineers. We bring out a quarterly magazine called the Mobility Engineering magazine. So in every quarterly edition, I write a couple of articles on some of these skills that we need to bring. And this has been going on for the last couple of years now. So there are quite a few articles in this series, which I would encourage the participants to look at to see how to create a structured approach towards building these skills. And these are all readily available in the Society of Automotive India website. But what I also want to bring to your attention is a very systematic and exhaustive study done by yet another SAE organization, the FISITA, which looked at Mobility Engineer 2030. And here they interviewed a lot of experts across industry, academia, and government labs to understand what they see as important skills that the future mobility industry would need. And the basis of this was a kind of shift that is happening in three major areas. One is the intelligence revolution, the AI and machine learning, data and analytics that's happening. The other is the energy revolution, the shift towards renewable energy and more efficient storage systems. And finally, the connectivity revolution, the connected vehicle, the rich data that it brings in, and the power of analytics. So we are basically looking at how the automotive industry is going to be shaped at the intersection of these three big revolutions, the intelligence revolution, the energy revolution, and also the connectivity revolution. That's why we see that there is a need to build a whole new set of skills. And a lot of the skills I'll talk about is centered around addressing the shift in terms of electrification, the automated driving, the connected cars, also the mobility on demand. I will keep these four areas in focus when I talk about the skills that we need to build. Of course, from an engineering domain knowledge, the traditional mechanical engineer is very valuable to the system. A lot of the vehicle design aspects are based on the concepts and ideas in the mechanical engineering domain that forms the foundation. Over and above which, we bring the concepts of electrical and electronics. So we need to introduce a lot of bridge courses, which would help a mechanical engineer to learn about electrical electronics and also vice versa. Then comes the software, because here we are talking about vehicle-to-vehicle connectivity and autonomous driving features. So basic familiarity with programming and also the basics of AI and machine learning, model-based controls, all this will be very valuable skills for a mobility engineer to possess. And finally, in terms of a system-level approach to solving many of these problems and keeping the environmental impact in mind when we are designing new technologies and new systems. These becomes very key focus areas for skill building. So this is a very simple visual representation of the kind of gamut of skills that we need to build. The base layer is the engineering domain knowledge, which is mechanical, electrical, electronics, and computer science. The mid layer is the integration skills that I talked about, which is quality, systems management, communication, and a very strong customer orientation. But the real differentiation, which would set us apart in a crowd, would be the top layer, which we refer to as the growth layer, which is having an innovative mindset, having the right ethics, and intelligently managing the risks, because there are a lot of inherent risk, technology risk, and also market risk involved in bringing these new technologies and products to market. And the last but not the least, in fact, the most important is the learnability, which is our ability to quickly learn new areas of technology and apply them. So we refer to this as competencies, which is not just knowing, but the ability to apply this to solve real world problems out there. Some of these you can pick it up in a classroom. So academia is well geared to build these skills, but some of them you'll pick them only in the industry. Sitting in a classroom, you will never be able to build those skills. And there is a whole set of skills which are at the interface of industry and academia. That means neither industry nor academia can build these skills on their own. It is only through collaboration we'll be able to build the skills. So that's where it becomes very important for the industry and academia to come together, not only to prepare the students, but also to prepare those early career professionals who are already in the industry to meet the needs of the future industry. So my current focus is to really strengthen this industry university collaboration, bringing a lot of focus into this much neglected area of collaboration between industry and academia. This is the best way to build the skills at scale and also in a very short duration. Having talked about engineering skills, because that's straightforward. Any technical person will be able to not only figure out what they have to learn, they will also learn it in a short time. But what will take much longer time is the cognitive skills that I talked about. And here I have listed at least 5 very important cognitive skills that will make us all very successful during this disruptive phase. The first being design thinking, second is exponential thinking, third is sustainable thinking, innovative thinking, and rational thinking. These 5 are the most valuable skills which will make any mobility engineer most useful to the organization. And here, in the interest of time, I just picked up 2 skills that I will spend a minute on. We have invested a lot on training our own engineers in design thinking, and that has yielded great dividends for us. So when we hire engineers, even from the best of best institutions, they are very well trained and they are very analytical in their approach. And exclusively, they are using their domain knowledge and their logical brain to solve problems. But we saw a lot of value if we can bring the brain and the heart together, which is the primary premise of this whole design thinking approach, is to understand what are the pain points of the customer and how to empower the customer through the kind of the innovations that we are pursuing. So whenever we hire new engineers, the very set of training we take them through is on design thinking. And this is not a rocket science. It's very easy to train our engineers in this very important area. And it's a very systematic approach, starting with understanding the customers, empathizing with them, and using that insight to define the right set of problems. Then it's all ideation, generating lots and lots of ideas, but not just stopping there, but quickly prototyping and testing. If you're able to master these 5 skills, we'll be able to really excel in design thinking. And this cuts across all the engineering domains. In fact, we have seen the maximum impact when we train our engineers on design thinking. The next area, because of the nature of electric mobility that we are talking about, is systems thinking. There is so much only that you can do by innovating on the electric vehicle as a product. There are a lot of dependencies on various things on the immediate environment. It could be the storage systems, it could be the charging infrastructure, it could be the internet connectivity, the cloud, the infrastructure, even the minerals, the lithium and the cobalt that goes into the batteries, ability to mine them efficiently, ability to mitigate some of the supply risk around these materials, and then making sure that we are generating clean electricity to charge our vehicles and use of smart grids. So there are so many dependencies in order to ensure that our customer gets maximum value from the electric vehicle that we are designing and manufacturing. So it's very important for the mobility engineer to not look at EV as a standalone product, but look at electric mobility as a very complex and interacting ecosystem and try to identify various problems at the interfaces and focus on those problems and solve them. That's where the real opportunity to innovate and make an impact really resides. So we need to train ourselves to be system thinkers rather than just focus on EV at a vehicle level. So I would like to wrap up with this chart, which kind of summarizes all that I tried to share in the last few minutes. So you have the engineering domain knowledge as a foundation layer, and then you have the integration skills as a middle layer, and then the growth mindset as a top layer. I think this would give us a very structured approach towards building the skills that we need, because we have very little time to build the skills. So we need to collaborate with as many smart people as possible and use this kind of a structured framework to build these skills on scale and in as short a time as possible. So I will take a pause now and wait for questions.
Thank you, Dr. Shankar. And it was a great session. Much needed things to the output. So we have a question around how does Mahindra and Mahindra foster a culture of continuous learning and innovation among its engineers?
Sure. So one of the most effective ways in which we are able to do this is what we call as a technical ladder, which is basically a technical career path. So at the Mahindra Research Valley, all our engineers are on a technical career path. What that means is the competencies that you need for your current role and for your next role and the next role are very well defined, so that you exactly know what competencies you need to build for your career growth. So your growth is very well in your hands. You are fully empowered to go ahead and build those skills and start using those skills so that you're already ready for the next role. So that's what the technical career path. We launched it almost about 5 years back. We call it as a tech ladder. And what comes along with that is lots and lots of trainings in many different technology domains. And all these trainings, anybody who is interested can nominate themselves and attend those trainings. And the second is also the promotions are based on assessment of the functional competencies of the person. It's not just based on how much time or experience they have put in a particular role, but it's based on how ready they are for the next role, which is a very rigorous assessment based on the functional competency of the person. So I think this is what has actually helped us to get a large number of engineers ready for this transition to EV.
Thank you, Dr. Shankar. Thank you so much. I would like to invite Mr. Ganesh to the dais for his session. Good afternoon, Mr. Ganesh.
Yes.
So, Mr. I'll just give a brief introduction and hand it over, sir. So, everyone, we have Mr. Ganesh Rao, who heads the ADAS R&D division at Continental Technical Center, Bangalore. He has over 21 years of experience in the automotive industry, with more than 15 of those years spent with Continental. Today, Mr. Rao will be discussing software-defined vehicles enabling automated driving. He firmly believes that SDVs are redefining our industry both in terms of technology adoption and value creation. Mr. Ganesh Rao, over to you, sir.
So, namaste everyone. My name is Ganesh Rao. I'm heading the R&D organization for ADAS and autonomous mobility in Continental Bangalore. All our panelists already talked quite in detail about software-defined vehicles, the mega trends that are defining them, the driving them, and the key technologies and so on. Let me talk briefly about one of the mega trends that is simultaneously, I think, running along with software-defined vehicles, which is automated driving. We are moving towards level 5 kind of a full autonomous vehicles. So how these technologies are being enabled by software-defined vehicles, I think this will be my theme, my talking point. So for software-defined vehicles, one of the key promise is that in the future vehicles will be always aware, always updated, and always safe. This is one of the key promises. And this is all of these three promises are relevant when it comes to automated driving. Right? Next slide, please. Right. There are 5 major global trends which are revolutionizing the vehicle architecture and moving them or pushing them towards software-defined vehicle architecture. The first one itself is automated driving. The clear transition from level 0, level 1 kind of a system towards at least level 3, where the vehicle can do fairly a good amount of automated driving on its own, and later towards level 4 and level 5, where they are completely autonomous. So this trend is continuous progression for the last 10 years, and this is going to be, I think there is a strong drive towards this. The same is also around cloud services. The need for the cloud services, the capability of the cloud technology providers is increasing day by day, and the automotive ecosystem can benefit a lot. Another key mega trend for sure is that consumers are looking at demanding that our vehicles behave like an IoT device in terms of connectivity, in terms of functions and features. Another key mega trend is also how consumers interact with the vehicles. That is the UX or the user HMI interactions with the vehicles. Maybe it is voice, maybe it is touch, and gestures and things like that. And also another big mega trend for sure is around shared mobility, right? All these mega trends are driving towards software-defined vehicle architecture. And this is not too far away into the future. And if you see even in Indian market today, there are quite a bit of vehicles, both from Tatas and Mahindras as well. They are premium flagship products. They have already built-in auto, right? Over-the-air updates it can do already. So there is a strong push towards IoT technologies. There is a strong push towards SDV architecture change already in India as well. And if you see in terms of numbers, by 26, close to 36% of the vehicle sales, they will have auto technology in them, right? 66% of the OEMs are already planning to partner with software firms and technology firms by 2026. Also, close to 640 billion worth of software-based functions and features and services will be, that will be the kind of a market availability. So this also opens up quite a bit of disruption in the ecosystem. The tier 1s, tier 0s, who are they? I mean, there is also a term called tier 0.5 and things like that. So there is quite a bit of value proposition. Different players are bringing quite a bit of disruption happening as well in the industry with this. Next slide. So what do we, just in terms of kind of a definition for software-defined vehicle, the way we see it, software-defined vehicle is where functions are enabled by software. Basically, kind of a decoupling from hardware and software. Of course, hardware is still important. One time, I think we'll deliver the hardware, but then continuously improve the functions and feature through software, through algorithms and deployment, right? Once vehicle was looked at as a closed system or a self-contained system, but going forward, it will be continuously updated, continuously made safe and so on, right? This is how we see software-defined vehicles, this decoupling from hardware to software, right? This is one of the strong themes and strong benefits we see with the software-defined vehicle architectures coming. Next slide, please. For a better visualization, if you see in the past systems, where hardware and the software are tightly coupled, once you sell your vehicle, the functions and features are already set, and they will set till the end of the vehicle, right? Vehicle's life. But going forward, the way we see it in the software-defined world, vehicles world, hardware, that is mechanical components or electronic components, they will fairly be stable. Once you sell a vehicle or once you deploy them, they're stable, but you can continuously improve the functions and features through software. There will be continuous development, continuous deployment of these software functionalities, of the algorithm functionality, and you will keep the product fresh for a long time. Next slide. Let me talk about one of the interesting partnerships we launched recently, because this is also relevant for automated driving. This was a partnership we announced in US with Aurora, which is a trucking company or a trucking aggregator. So we partnered with them with an intent that we bring level 4 automated driving by 2027 to US between 2 cities. So basically these huge trucks you would have seen in the movies and you would have seen in US. So they will be traveling between 2 cities completely autonomously, and they will be driving 24/7 without a driver as a backup, completely driving themselves between 2 cities, right? They will for sure utilize the full portfolio of Continental in terms of hardware. When we talk about hardware in this context, it's primarily the control units, it is the sensor suite, and the ADC, the domain controllers, and so on, right? When we talk about software, it's the complete perception stack, the perception stack or the software and algorithm for radars and cameras, the path planning algorithms, the driving function algorithms, the emergency algorithm, the lane, the fallback algorithms, and right. So this kind of a system is level 4 because it has 2 separate paths as well. One is called as a full stack path, but there is also a fallback path. Just please note, if there is a failure in one of the main path, the vehicle can still drive on its own in the fallback path for 30 kilometers at least, and then go to a service station, right? This is the kind of safety that is needed when we talk about automated driving, right? You can also imagine these vehicles are huge vehicles, both in terms of size and the weight, right? So maneuvering them, bringing them to a safe stop in a garage, this is the target of a fallback system as well. So there will be continuously 2 full systems running, right? 2 full sensor systems, 2 separate sensor systems, 2 separate compute platforms, and path planning algorithms and so on. But this is also a place, as I talked about previously, hardware and software separation. So we will sell or we will deploy our hardware in terms of sensors, radar, cameras, the computational platform once, but we get paid when the vehicles are running only, right? So this is also a new thing for us. This is also a new kind of a revenue generation for us, but also liability as well, because we need to ensure that they're always running. If there is a breakage of the system anywhere, we need to immediately learn why it failed in terms of, okay, if there was an accident, okay, we need to learn why it happened. Then we need to ensure that that learning gets deployed into all the vehicles immediately. If there is a construction area in a certain vehicle and vehicle is not able to detect it, then we need to learn that very fast and deploy it in our full fleet, right? So this is the point where separation of hardware and software helps. You can continuously update. We'll talk about it briefly as well. As I said, it's also our first it's also in the industry, the first kind of a partnership, a level 4 or a level, of automated driving system being deployed by 2027 in US between 2 cities, right? There's quite a bit of material also published. Please have a look. Next slide, Venkatesh. Yeah, just to go deeply in terms of how to explain this complexity of this kind. Can you previous slide? Yeah, just stay here for just to explain in terms of complexity of a level 4 or a level 5 system. The circles which you see in this image of the truck are actually different sensor clusters. What you see in the top is a sensor cluster which will have one lidar, one which is called as a 4D radar, and then some cameras in the top. Then there is a side, two side sensor clusters again, having 4D imaging radars and cameras and lidars. Similarly, there will be control units, as I said, 2 separate computational paths. Then also on the sides and the front, some more sensor clusters. So this is the complexity of a level 4 system, right? And ensuring that this kind of a system is continuously updated, it's always safe and always aware. This is the challenge which can be only managed with the SDV or a full-fledged software-defined vehicle architecture. right? If we don't build a system top down like this or ground up like this, it's extremely difficult, right? So this is the benefit, or this is the kind of a operational benefit that we get as a system supplier through the SDV and automated driving combination. Can you go to next slide? Right. I talked about hardware and software decoupling and the benefits of it. In this slide, trying to explain what and all we can achieve with the software-defined vehicle, not just for the end consumer, not just for the in terms of value proposition, but also at the same time in engineering, how quickly we can deploy. When we talk about automated driving, you see the left bubble. Automated driving is actually data-driven development, because if you talk about level 1, level 2 kind of an ADAS system, we typically talk about a data of 10 petabytes or 20 petabytes. I mean, it's always in tens of petabytes. But when we talk about level 4 or level 5 systems, fully automated driving, we are already talking about hundreds of petabytes, right? And what are these data? These are the data of the real world, the camera images, the radar images, and these are the LiDAR images, which we use later to train our AI algorithms, right? So this kind of a data-driven development is enabled by software-defined vehicles. I mean, and then the next topic is also around the virtual development, right? So this is also where we can really reduce by 50% or greater than 50% of our development efforts or test efforts. Another key feature is also the shorter development, test, and integration cycles. Can we achieve from the conceptualization of a change? Can we bring the change to the road within a day? Right. This is a kind of a holy grail we are trying to push towards, and this is only possible through software-defined vehicle architectures. And this is a need for, as I said, also for the trucks, level 4 trucks that I talked about, even in those kind of a programs. This is the kind of need that we look for. Can we bring the change as early as possible to the real world, right? For sure, there are new business models, as we said. As we break hardware with software, there is a great level of possibility to generate money, and new business models can emerge. Also, what opens up is new software architectures, the partnership with the OEMs, the technology providers, Tier 1, Tier 2, and so on. So what is also critical here is new platforms, shorter time to market. New platforms can come within 1 year. It used to be 1.5 years to 2-3 years earlier. It's really reducing a lot. Yeah. Next slide. Let me just now stress a bit more on the data-driven development. Automated driving, as I said, is a data intensive. When we talk about level 4, level 5, hundreds of petabytes of data. As you see in the left corner, this data is actually both for training purposes, training our AI algorithms, you need data, but also to validate, you need data, huge amounts of data in hundreds of petabytes, right? So this is where trying to achieve this kind of a maturity just alone is impossible. That's where we partner a lot. If you see Continental, we have partnered with AWS for the cloud services, for the development services. We partnered with the industry player Aurora. We partner with the chip manufacturer Umbrella, so that we have a scaled version of the technology as well. And also what is clear is something called as a cloud-first strategy, end-to-end data management in the cloud. You cannot have, I mean, I remember the cases where you have the recordings of different parts of the world, then you put them in hard disks, then you ship it all around the world, where your engineers will use it to train the algorithms and validate and so on. This cannot work anymore. So this is where cloud-first strategy matters. Also, what is important is virtual ECU concepts, which is very, very clear. That also moves towards cloud a lot. Another key element is called as silent testing, the ability to test your functions parallelly along in the real world. You can actually deploy and test, and you can actually go for full deployment or full production, right? So, and continuous integration and deployment as well. One simple example to highlight, this is a pretty famous case as well when Elon Musk talked about capabilities of his the full capability of his systems, of his vehicle and the development system, where he said, one time I think they faced a problem that when their cars were sold in Australia, the cars were not detecting the kangaroos, but the kangaroos crossed the road, they jumped, but the expectation is that your vehicle brakes and there are kangaroos in front of the vehicles that doesn't go and hit. So they collected the data using their vehicles, they uploaded it to the cloud, then they brought it, the developers trained their algorithms and it was deployed, right? This kind of benefit, this kind of feature development and deployment at record speed, I think this is the promise of a software-defined vehicle, right? Just imagining having the same here. If there is an accident, okay, and a vehicle will learn from it, you train your algorithms, you immediately give the benefit of the new algo or the new development to all the millions of customers, right? So this is the kind of promise what software-defined vehicle is giving to the automated driving mega trend as well. Next slide. Yeah, this is my last slide, just as a summary slide. Both the mega trends of software-defined vehicles and automated driving are going parallel and benefiting a lot, one driving each other and one enabling each other. You see in this slide, the whole promise of automated driving is that the control or the responsibility moves away from human towards the system or the machine, right? This is supposed to be beneficial because it's supposed to reduce accidents, because humans get stressed, humans get distracted, they get tired and so on, and that's supposed to cause accidents. And so machines don't get tired, they don't get distracted and so on. So this is where the control will move more and more towards the machines, and that is also how it looks. You start from level 0 automation, which is primarily warning systems, then you move towards longitudinal or lateral control, then systems where it can do both. And if you see level 2 systems, even today, a lot of Indian OEMs have it. They are in the market as well. Just to give examples, both Tatas and Mahindras have level 2 systems on Indian roads. They're working pretty well. And also other OEMs, right? Level 3 is where the control moves to this machine much more strongly. And this is where there are only 2 to 3 players in the world where it is officially level 3. There is one system from Honda, one from Mercedes, and one from BMW. Level 4 and level 5 are difficult to achieve. For sure, there is Google Car, there are systems in US, many more systems in US and also in China and so on, but they're all limited to either one city or one route, right? Because scaling them is technology intensive, data intensive, and also cost, right? So their systems are there and it will go towards it. I mean, if you see technology feasibilities are already demonstrated and it will happen. There are also many Indian players, Indian startups trying level 5 kind of an automation as well, right? With that said, both automated driving and software-defined vehicles are a reality, and these mega trends will continue. This is also, both the trends are very technology intensive and software intensive. And this is a benefit for the Indian ecosystem as well, for all the players, whether they are in services, they are in tier ones, OEMs, and so on, also in the universities, because this is where a lot of innovation can happen. The strength of Indian ecosystem can also come together. And these technologies, there will also be a huge demand for talents. So even the previous speakers talked about what kind of technologies. I also covered quite a bit of it. These are the mega trend. These are the technologies where we have a lot of demand as well. Yeah? With that said, thanks again, ET Auto and also the Skill-Lync organization. Any questions?
Thank you so much, Mr. Ganesh. A lot of real life case studies and a lot of real examples. Very exciting to see the developments here. So one question specifically is how Continental integrates AI into ADAS technologies to enhance vehicle safety and performance.
Yeah, when we talk about ADAS and also automated driving, the AI is actually used for computer vision. Computer vision is basically camera function. You get the camera images and then you recognize objects from it. You make sense of those objects, or you get radar images or radar data, and then you make objects out of it, and then you fuse them. And so this is the function called as perception. So AI is used in perception already. The specific field is called as computer vision. Initially started with standard computer vision, SVMs and so on. Later it moves already. Now it's typically DNNs. So deep learning models are already used heavily. Yeah, so that's the standard use case for AI in ADAS, but also you use it for path planning, you use it for driving functions and so on.
Thank you, Mr. Ganesh. I welcome Mr. Daniel Davenport on the dais. Good morning, Mr. Daniel. Our final guest speaker for the session. Mr. Davenport is a digital innovation expert with nearly 3 decades of experience. As a Senior Director of Industry Solutions at NTT Data, Mr. Davenport specializes in hybrid network and cloud solutions, collaborating with automotive and manufacturing leaders to transform their digital aspirations into reality. Today, he will discuss the challenges and opportunities in advancing SDVs. Let's give a warm welcome to Mr. Daniel.
Excellent. Thank you very much. Is my audio okay, Vintat?
Yes.
Excellent. Excellent. Well, first of all, thank you very much for having me this morning. It's a hard act to follow all of these esteemed speakers, but I'm going to try and bring maybe something a little bit different to the equation. So I'm going to share my screen right now. All right, and let's get full screen. Excellent. So I'm going to talk this morning about smarter software-defined vehicles. And I'm not going to really focus on the vehicle. I'm going to focus on the approach to developing the applications, and we'll see how we get there. Just a quick word about me. I've only been focused on automotive for the last 8 years, but I've had a front row seat to the software eating the world concept. I started a digital agency in '94, made a lot of websites for Fortune 500 companies. I was on both sides of the feature phone to smartphone transition, and I think that there's some things that we can learn about those transitions and that we can take and apply to our ability to develop really interesting customer-focused automotive applications. So I'm just using this as a kind of a reference point. The other speakers have done a fantastic job of illuminating many of these technical solutions and ecosystems. This is a great place to be. This is a lot further along. Heterogeneous systems, virtual cloud platforms, cloud first approaches, which I think we'll see in a couple of slides. So we've got a great start. But what I'm suggesting is that there are problems that are still outside of the conversation. And so I'd like to borrow some credibility from a good friend of mine to highlight a couple of different issues with SDV progress. Scott Runner and I worked together at Capgemini and developed a lot of the cloud mobility solutions that we had there. Most recently, Scott was the CEO of Cariad North America. So he's got an interesting perspective from inside the industry. And he wrote an article, which I'd invite you all to take a look at, that he published on LinkedIn at the beginning of the month, highlighting these 6 problems specifically as challenges to get to the place where we're actually creating sophisticated mobile applications and mobile ecosystems. So I'm just going to talk quickly about the first 2. Right now, and with the understanding that I'm mainly thinking about the American and European markets, the Chinese market is a little bit different. And while it's very interesting, I think that the Indian market is the true place that a lot of innovation is going to happen. We can talk about that in a minute. But right now, especially in the US, the 2 main in-car applications are maps and radio or infotainment. There's not a lot of sophistication there. I think that we need to drive towards thinking about what is going to be helpful for the customer and we spend a lot of time thinking about our engineering things, but not as much around what the consumer demand is going to be. Point two, I think, is really interesting. I don't know about you guys, but I've got a new Subaru, and when I put my cell phone in the Subaru, I put it in the cup holder. So there's still no thought from the OEMs about how to place the actual phone that you're going to use to power many of the systems that we all know and love, like CarPlay or Android Automotive. Is like a physical disconnect there that also extends into thinking about multiple people in a car. One of Scott's ideas is that you need to have a multi-device platform for everyone in the car to be able to participate in the control and the selection of infotainment and things like that. I think that there is a real need for user experience strategy, digital strategy, things that we developed along the way as we were understanding what mobile applications were and how to make them. I think there's a lot of parallels between that process and the process that we're all going through now, trying to imagine these new software-defined vehicles and how they're going to be used. So there's three themes that I think that Scott pulled out, and we talk a good bit. So I think that these themes have somewhat been touched upon here, but that the customer-centric innovation is the one that really is the big opportunity. And so there's a couple of things, and Mr. Rao will recognize some of these slides. There's a few things that I think are pointing the way. One of them is the ability to do testing on digital twins or virtualized hardware equipment. With that virtualized hardware equipment, you can now open up a lot more capacity and velocity for testing new use cases or new innovations. The cloud-first strategy is so important, and the virtual engineering workbenches, I think, which Continental has really been way out in front, and I'm using these because they're referenced so much publicly. It's just a fantastic ability to start to democratize and open up the ability to write applications. And then the last thing I think is that we really need to start thinking about a modern user interface. So generally, as new technology comes along, it takes a while to get to a sophisticated design language. And I could have had Apple CarPlay's new enhanced UI kit up here, but I saw this and I thought it was more interesting. I thought you guys might like it too. This is a small design shop called Black Box Infinite, and they have kind of reimagined some classic car interfaces using the Apple UI kit. So I think what my main point is on this is it's time to start thinking about our interfaces in our cars in a much more sophisticated way. And so that's going to take, in addition to engineers, it's going to take front-end UI developers, it's going to take experienced designers, and it's going to take those kinds of people coming together with what Dr. Shankar called the integration skills, I believe, that are so important in this next phase. So as we look at, this is one thing that Scott said, that they spend so much time focusing on things that the consumer does not know or does maybe not even care about. And so as we think about what's coming next and how to get to where we all want to be, it's, I think, going to be increasingly important to focus on outcomes and benefits for the user, because even though Mr. Rao correctly pointed out that the control of the actual vehicle is shifting from the human to the machine, there's still humans in the vehicle, and they're the ones that we're trying to build things for. They're the ones that we're trying to create a new mobility ecosystem to improve their lives and the lives of their families. So one thing that I think is really important is that we think about the unique capabilities of a vehicle, what is important and what is uniquely a mobile experience. I really don't think anybody's cracked the code on that quite yet. And I think that there's a lot of room for improvement and innovation there. And in the last couple of seconds that I've got, What does the mobility first company look like? I'm going to posit that Ford Pro is a fantastic example where they looked at one of their most popular products, the Ford F-150. It's a truck. Who uses that truck? Many times small contractors. What do those folks need? Well, they need a mobile CRM so that they can process work orders. They need to understand how charging works and where they can charge on the way to their next job. I think Ford has done a really interesting job of creating a mobility offering for a specific user group, and then they've supported that user group with applications that help them in their day-to-day life and to conduct business more efficiently. So with that, I'll open up to any questions that anybody might have, but also just thank everyone so much for your time today, and thanks to Skill-Lync.
Thank you so much, Daniel. Just give me a second, pulling up the questions. Yes, so specific question around virtual ECU workbenches. So what are the type of developments happening here? How do you look at this in the future?
Yeah, sure. And that's probably a better question for Mr. Rao, but I'll take a swing at it. So there are the ability to test hardware in a digital twin environment is a huge accelerator towards features and functionalities. And as Mr. Rao pointed out, the cloud-first strategy is a critical component of that capability. We've seen a lot of regional development, but we've also seen the need for a global development platform for many, if not all, of major OEMs or global entities. And so they need to be able to develop features and applications that are appropriate for the Chinese market, the European market, the American market, but also share some consistency across models so that you're not recreating code regionally. So I think that you're going to see this cloud-first methodology really promote, become more prominent in the next year or so, especially with the advances like Mr. Kulkarni referenced with SOPI and organizations like that.
Thank you, Mr. Dan. One other question: how does entity data approach the challenge of integrating new digital innovation in existing automotive systems?
Yeah, fantastic question. NTT is a pioneer and an innovator in many telecommunication systems, and in fact, we have an MNVO that's a global mobile virtual network with a global eSIM card, and I think that we're going to see a lot of OEMs start to move towards a global view of their in-car connectivity. So NTT spent a lot of time thinking about how we connect the cars, how we keep the cars connected, and then in the cars, how people interact with them, especially using things like agent-based Gen AI interfaces.
Thank you so much, Mr. Daniel.
Thank you very much.
We'll have a quick Q&A for all the panel members. I invite everybody to be on this. We'll do at least one questions per person in the interest of time. Thank you so much for staying till the end of the session, everybody. And so to Mr. Aaswad, there's a question from one of our internal team members. So specifically, he's our in-house SDV specialist. He would like to know about containerization technology that TCS is using, considering Docker is established as not suitable.
Okay, so yeah, so Docker is obviously one of the obvious go-tos. But what we have also played with, we started a little bit playing with the Linux containers itself, LXC, but that's again not going to be much prevalent. What we are currently playing with is Podman. So that's another OCI-based container technology. But so those are the two typically. Dockers and Podmans is what we are currently experimenting with.
Understood. So, Mr. Ganesh Rao, so a question around regulatory and infrastructure challenges in India. So what do you see as the key factors that could influence successful deployment of autonomous driving technologies in the Indian market?
Yeah, already, as I said, there is quite a huge consumer interest, and there is already level 2 kind of systems deployed. For sure, still the challenges are in terms of the really heterogeneity of our traffic participants. I mean, it's there are two-wheelers, bicycles, everything mixed. I think it's too much heterogeneous, so that's actually quite a difficult challenge many times. But there are systems already deployed. Regulations as well are coming, hopefully in 27, 28 kind of time frames. They are getting drafted. There should be something coming up pretty soon as well. That should help. I think we have the technologies at hand. Should be good enough.
Noted, sir. So to Dr. Shankar, can you discuss the importance of intellectual property in sustaining automotive innovation?
Absolutely. I think it's very, very important to have a very clear IP strategy in many of these emerging technology areas. Before we start investing in certain technologies, it's very important to understand the landscape and see what is already out there, which is a crowded space versus where there is a white space for us to innovate and create our own IP. That is one dimension to looking at IP and integrating it with innovation. The second dimension is to make sure that we are not infringing on anybody else's IP when we take forward and put our technology into a product. So it's very important for us to understand not only our IP, but also everybody else's IP and make sure that we have everything IP protected, everything that goes into the product. Either we should own it or we should have licensed it from whoever owns it. So it becomes very important for every inventor and innovator in the organization to be IP savvy. Because if he studies the IP and understands what is patentable and what is not, then he'll be able to prioritize the various ideas that he's working on and make sure that his effort translates to a patent. And imagine a patent is going to serve for the next 20 years to the organization. So that's the biggest contribution any employee can make to his organization. So I think it's going to be an integral part going forward for all inventors and innovators to bring IP as part of their technology and innovation strategy. I think that's very important.
Thank you, sir. Dr. Ranga, how do you personally foresee the future of capability building in automotive industry? I guess, Dr. Shankar, you could take up the same question. How do you personally,
About capability building, right? So
yes.
Capability building has been happening across the industry at different levels. But what is new today is that scale at which this has to happen. It's not just a few employees who have to be trained. Almost every single employee across the organization has to be trained. And this is, again, people at different levels. For example, at a CXO level, the technology has to be introduced in a manner more from a strategic perspective and from a business context perspective. And at a mid-layer, a mid-manager would need to understand technology in terms of at a systems level, how it's going to enable the performance and how it's going to improve certain differentiating features. And at an individual contributor level, the building blocks of technology, how to build a pipeline of technologies that will feed into the next-gen products. So the technology has to be continuously, it's changing. So people at all levels have to be continuously upskilled. So that is the scale at which this is happening. So that is something new. We have never done it in the past. Second is the time that we have to do all this is very short because technology is changing so rapidly. You're talking about exponentially growing technologies. Like we had this Moore's law, computing power doubling every 18 months. Almost all the technologies that we are talking today are either doubling in 18 months or 12 months or some even in 6 months. So we have very little time to learn all these new technologies and start applying. So these two, the scale and the speed at which we have to do is what is making it very, very challenging today. And it's not only depth, but also breadth that we have to build for all our engineers. Each person has some depth in some area, but breadth also becomes equally important. You should be very familiar with many adjacent domains. That's where he can make the best impact. So I think this should be the focus. How do we address these three challenges? One is the scale, second is the speed, and the third is the breadth versus depth. the right balance. Sure.
Thank you, Dr. Shankar. Mr. Aaswad, there is a question about can you discuss the importance of middleware approaches in the development of modern vehicle software platforms?
Oh, wow. How many hours do I have? I think I'll try to keep this short. That's going to be tough. But it's essentially the most important piece in any of the newer softwares. I mean, it's been there for, like I said, AutoSAR has been there for 20 years, and it's one of the middleware ways of doing things, so to say, in the ECU software way. But there are more and more players there. But what a middleware provides essentially is twofold, right? One is the connection to the hardware that's below, so that none of the other entities even know what hardware they are running on, and critically providing the abstraction or the independence of all the features or applications, as we call, running on top. So that's the abstraction and the independence from the hardware. And we have touched upon a lot of these different elements there in everybody's talk of how that independence is important and why everybody's trying to receive it. So the only last point there I'll mention is, now when it was all these distributed and embedded ECUs, it was fairly simple, either a direct OSEC based or a scheduler based, and some middleware may or may not be implemented. Then AutoSAR came. Now adaptive AutoSAR is there, but then there are more flavors that are available. You could have a ROS based system, which will provide its own kind of middleware, or you would implement a middleware piece on its own, but all of them will have the similar structure. Somebody has to govern the communication, somebody has to govern the diagnostics, somebody has to govern the life cycle. So those pieces will be common. It's whether you're using APIs of a standardized middleware such as AutoSAR, or are you defining something on your own? That's a decision based on, you can weigh in the merits. There is cost, there is time, there is maintainability, so on and so forth. But yeah, middleware is, I would say, the glue that is needed for any long-term maintenance and managing the software over a long, long time, which we have. Our vehicle lasts for at least 15 to 20 years. So yeah, it's critical.
Thanks. Thank you, Mr. Ashwin. The final question to Mr. Daniel. So what would be a market focus for connected vehicles in the United States?
The market focus for connected vehicles in the United States, I would say, is connecting the vehicles right now. We still don't have a smooth path for our users to connect their vehicles. Do you go to the OEM? Do you go to the carrier? How do you get the car connected? There's a lot of confusion there for regular people. So I think we really need to make it easier to have an always-on connected vehicle, and that's going to unlock lots of capabilities.
Goes back to your point about customer focus.
Absolutely.
Thanks, everybody. Thanks to all the speakers. Just hand over the session to Mr. Dhruv Mathur, who is the Enterprise Business Head. He'll close with the vote of thanks and the closing remarks.
Okay. Hey, thank you, Venkat. I'll again thanks once again to all our speakers who have spent time today to join us, as well as our partner ET Auto, who has been working on this project and the event for a while now. And special thanks to all the viewers who have joined from across the country for this event. We wish to continue and support our automotive clients and do more similar thought leadership events going forward as well. We have been also receiving a lot of requests about receiving the Automotive Detailed Talent Trend Report. Just to also share with everyone that after this event, within a week's time, we'll share the Talent Trend Report with all the viewers who have attended this seminar. I'll also take this opportunity and spend 2 minutes and share what work we have been doing within the automotive space within Skill-Lync. So what you're seeing on the screen is a quick snapshot of Skill-Lync in a page within the B2B segment that we have been working with. Our goal, our mission has been to create top-notch content within the automotive space in the technology sector in the automotive space. And to do that, we have been the only firm in the country who has created more than 250 plus digital courses within the automotive space. We have done more than 1,500 plus boot camps on the ground with our automotive partners, and currently more than 70% of the automotive companies in the country has trusted Skill-Lync for their reskilling initiatives. More than 150 plus companies across the country has been leveraging our platform, and more than 35,000 employees working in these organizations, whether it is GET or whether their existing employees, have been reskilled through Skill-Lync courses and platform. And through our automotive partners support and the creation, we have been able to run these programs with more than 9.5 plus NPS score during these programs. I think this will just make it simple for from an overview perspective in terms of what overall Skill-Lync has been doing in the automotive space. We majorly work in three verticals. One is mechanical, second is electrical electronics, and third is digital engineering, all specifically focused towards automotive and the new age skills within automotive. Each and every single domain that you are seeing here, where we work in depth, and we have created content with our automotive partners at all levels, from basic, intermediate to advanced. And a lot of trends around design, EV, software-defined vehicles, we have been supporting and working with our automotive clients very closely. As I said, in the last few years, a lot of our automotive clients have trusted us really well. Within automotive, we work in all the three gamuts. So for example, OEMs to tier ones to engineering services firms, where we work with the automotive and the transportation division there, to a lot of global capability centers within the automotive space. We have been working the automotive clients have been kind enough to help us create also the new age content that we are currently working with. With this, I'll like to thank everyone who has joined today with this event, and all the teammates within Skill-Lync who have been supporting this event, and the ET Auto team who have been supporting with us with the event. Thank you once again, and have a fantastic evening and a great weekend, team. Thank you, everyone.
Thank you, Dhruv. I hope we gave a balanced event here on the talent side and on the technical side. Thanks everyone for joining in. Have a great weekend.
Thank you, everyone. Bye-bye.